Right. Are we on? So, hello everyone. First thing I want to say is I'm streaming onto Charles's channel. He's deputized me. Where's my pin? Here we go. It's on this side. He's deputized me to be on his channel for the day. Now there's a couple of setups with the stream whereby I can't see the chat through his system. So I'm on a bit of a delay. So I apologize. I'll be a bit slower to respond than would be normal if Charles was in charge. Uh, though I will say we're going to do something a little bit different today than normally what we do on the channel. So normally it's sort of a Q&A, question answer type thing, but it's a bit hard to do a Q&A alone when normally it's meant to be a back and forth. So I'm going to try my best to cover a topic I want to talk about, and I'll still answer questions if anybody has any as I go. But I'm going to take a very slow and long-winded approach to solving a particular problem in terms of variable usage in Unity. So let's see how this goes. Give me 1 second, and right. Let's jump on over to my code. Right. And we'll jump that to the console. Right, okay, let me get started here. So, what I want to do is I want to focus on a very simple user requirement, which is we're going to talk about a conceptual idea of having health. So, we're going to pretend we've received this requirement to make a character, an NPC, who's got a health value. So, let me just clear out a couple of things I was testing earlier. So, we're going to make a very simple NPC. So, this is our starting script. I'm going to clear out some of the boring basic stuff. And we're going to pretend someone has asked us to make a character in a game that has a health value. And we're going to step through the requirement changes as the project goes and how we will alter and sort of improve that as it goes on. So, very first thing is we need health. That's going to start with something really basic. Let me just see if I can up the mic a little bit. Let me know if that helps. I talk quite low in general, so I apologize. You might have to up the mic on your end. So what we've got here is a... there we go. I think that's about max about mic on my end. I apologize. You might have to turn it up as well on your side. I'll try to speak a little bit louder. So I have a health field, and technically speaking, this has already fulfilled the requirement. If someone says, I need a character with health, we've technically already done it, right? We have health. But that's not very useful to us because we can't really change the health value. So the next requirement that someone might come along with is, I want to be able to set the health value. Well, that's fine. We can just set it to 100. So we now have a health value at 100. Right. Not very exciting. But the problem we have is this is now in code. So if we're talking about clean code practices, the reason for it is we want to be able to change and alter this this value in real time as the game progresses, which we can't do now because every time we want to change health, we're going to have to change it inside of the code. So how do we solve that problem? We make it public. Now, I know, just for anybody who's wondering, this is really, really slow and going through the process, and it may seem boring, but I'm really trying to get you to think about the procedures of thinking through what each word and line of code adds. Trust me, we'll get somewhere more interesting as we go, but you're just going to have to follow along with me while we get there. There's a method to my madness. So, we now have health. It is now a public field. We can now set it as the game is playing or running, which is great because we're now live and running, and I'm able to change this value. So that's pretty good. But the next thing we might want to do is, I added that during live, and let me do this again, NPC. The problem we now have, though, is even though I can set it while it's live, there's still the problem that I can set it to potentially invalid values. So I can set it down to minus 70 or whatever else ranges I don't want. So how do we solve that problem? Well, that's the next problem we have. We're going to use a range attribute. So range 0 to 100. And if I reset this script, we're now at 100. and I can now slide between 0 and 100. And that's pretty good. We've now added a range validator to this script. So even as we're running, we can make sure that we can't go outside of those invalid ranges. So we've solved that next requirement. We now have a health value and it has a range attribute. But the next requirement is if you have a health upgrade in your game, you might want to increase the maximum health range while the game is running and give someone more health. The problem is though, is that's back in code. So if we go back here, the range attribute is written into the code and we have the same problem, right? We're going to have to edit the script to change the maximum health value. So if I was to go and make public int max health, and I'll say the max health is equal to 120. See if that shows up as well. So I want to use this max health value to gate the values of this range. Now, if I try to do that, and I use max health here, Unity is going to give out to me. It won't let me use this live variable inside of the range attribute. So here's our first problem. We cannot use the range attribute for this kind of live gating of a value. So let's try to fix that. In attribute, we can apply this differently. We can use an onValidate function. So what does onValidate do? Well, every time we change a value over here, we can apply some validation rule. So in this case, we can say health is equal to mathf.clamp, and we can go between 0. Let's clamp the health to between 0 and max health. Yeah, I can zoom in a little bit as well. Here we go. Let me zoom in. Let me know if that's any better. So we now have a validate function to help us gate these two values. Let me know if the stream is back. It seems to be buffering a little bit. I apologize. My internet's not great over here in Ireland. Hopefully, though, you didn't miss too much. All I'm saying is that we now want to apply a range value to gate this health. And we tried using the range attribute, but the range attribute is working in at code time, and it's working when you're compiling. It doesn't work in real time when you're editing. But with the addition of this max health field, what I can do now is if I try to change the health value, it will gate to between 0 and max health, but I now have the freedom of controlling max health as well. So this is an improvement over using the range attribute. Now, if you know the min-max value at the time of using the variable, probably a good place to use it. Like, for example, I fully intend to not be able to have a max health greater than 200 during the entire lifetime of my application, and it should probably stay somewhere around 100. So we're going to say like that. So this gives me the freedom to use both, right? So now, if I go back to the inspector, I have a max health that can go up as far as 200, and I have a health value that will gate to whatever that value is. So this is pretty good. I really want to pause here for a second because I've kind of written a lot of code. I want to just point out the fact that I'm trying to add each line here to solve some requirement or dependency. The first one was we need to have NPCs who have health. Great. Second one, we need to be able to change that health during the runtime of the application. Great. We added that by making it public. But we need to have a max health. But we need to then have the max health changeable in runtime as the application grows. So each line has some purpose for me adding it, right? And this is something I really want to focus as I keep extending this. A lot of people ask questions like, what is the correct way to use a variable in terms of, oh, should I use serialized field? Should I make it public? Should I have various access methods? I'm hoping by stepping through it in this manner, it'll help you figure out the answers to those questions by applying the rules that match the requirements you have. So, as for where we are at the moment, we have a health value and a max health, and everything works fine. So theoretically, we've hit all of the requirements we have. But we've introduced a bug. Now, let me demonstrate what that bug is. So if I do an NPC tester, now, ignore the code in the NPC tester script. This is a test script. This is bad practice. I'm doing this purely to demonstrate. So don't look too carefully at the NPC tester script. we're focusing purely on the NPC script for the time being. So I'm going to say, let's just grab a reference to the NPC. I'm going to make a desired health value. I'll set it to 100. And I'll do a sin of setting the value in real time live. So we're going to set the health equal to desired health. Don't do this. I'm doing this for a test script. Like I said, ignore the NPC tester. We're really focusing on the NPC script, and I just want to use this to demonstrate a fact about it. So just a quick reminder, have a look again over at this code and see what the NPC tester is doing. Now, we'll head over to NPC first, right? So I want to really focus on this. We have a public health field, we have a validate function, and we have our max health. And the validate function is validating the health field whenever a change is made to this script. But there's a side effect, which is, when is this applied? So if I run this now, and I start to change the desired health value, everything looks great until I start to go into negative values. So we actually have a clamp on this health value based on the max health. But how is it going down to minus 70? Well, if I slide this value, that's clamped, but this is going outside of the editor. So that's the next thing I want to mention. When you look at this onValidate function, it solved the problem of having a real-time solution to setting a max health. But what it has introduced is the problem that this only applies on editor changes. So the fact that I'm changing the code over here at runtime is basically, the problem is that there are two ways in which our script can be edited. It can either be edited by other scripts or it can be edited by the Unity inspector. Oh yeah, sorry about this. If it keeps shrinking, let me know. So how do we solve this problem? Well, the reason we have this problem is because the field is public. If I go back here, the health is public, and that's how we can access it. And you cannot add validation logic on a field. You can do it here because this is based on the editor serializer. But if I have this public, I cannot ensure the same clamping and validation is happening. So how do we solve this problem? Well, we have to not make it public. So it has to be private. So health is private. So that's our first lesson. Do not use public fields. There are very rare cases. Ignore them. Let's say for almost every single case, make sure fields, aka class level variables, just don't use public on them for a number of reasons, but we've seen one of them at the moment, which is even if you do validation logic, it may not apply at a code level. So next up, I want to comment this out for a second, because it's not relevant, and we're going to focus exclusively on the NPC script again. So looking at the NPC script, we've now lost the ability to look at the health field. Why is that? Well, because literally it is now private again. So how do we solve that problem? We still want to see it in the inspector. We just don't want to allow people to set invalid and negative values or outside of our max range values from external scripts. Well, that's where the serialized field attribute comes in. So this will hopefully answer the question as to why you use serialized field. Well, if I go back now, we now have access to our health field again. Health is now correctly clamped to the max health value we have as the second parameter, but we cannot access it inside of the NPC tester. If I go back and try to access it, you're going to get an error saying that it's private. And that's what we want, right? We don't want someone to be able to set the health to minus 500 when very clearly our intentions were set in the NPC class that it's clamped to a particular value. So each one of these lines that I'm adding is meant to solve some kind of a problem or add some feature. So up to this point, we've now got guarded safety of our ranges on the health field that can be accessed from the inspector. But we do still want to be able to change the code from external scripts, right? We still want this NPC tester to work. This could be a health pickup or something, or you want some example where the health can be changed. You just want it to conform to the same rules that we've applied in terms of the clamping for limit to the max health. So how do we do that? Well, we need to create a method that will do that for us. In programming terms, it's called a mutator. So let's make a mutator. So a mutator is pretty straightforward. We'll call it set health, give it a new health value, and we will literally set health equal to new health. Right, that is our mutator. It's not the most complicated code in the world, but you get the idea. It works. So how do we use it? Same as any other function. Now, instead of accessing the field directly, we can call setHealth and pass in the new desired health. And if we run this, functionally it's the same. We still have this safety in the inspector, but when we run it, that should jump to 100 because it's being set to the desired health. And as we move the values, look at this, we can go outside the value range again. So we still have the problem, right? We haven't solved the issue that we want to avoid the ability to set the values to negative values. But we have one thing that's different now. We're not accessing the health value by a field. We're accessing it by a mutator method. And that gives us one extra bit of functionality we didn't have before, which is a place to perform validation. So if I move this back out to a, oh, it won't let me do it there. Let me do it manually. If I move this back out to a full method body, we have this line, but if we were to just copy this line instead and clamp it to max health, and we will clamp the new health value. So now we take in a new health, we clamp it between the min and max, and we set it to the health. It's the same code that's being run in the validate function. So if I was to run this now, we should have clamping. Despite the fact that we're setting crazy desired health values, it's still limiting itself to the value of max health. So I can increase what the max health is, but it will, no matter how much I desire the health to go to, the validation is perfectly locking it down. So it's very long-winded and we're going through this very slowly, but I want to point out that each section of, let me move the code a little bit here. Maybe a little bit smaller. Didn't think there'd be this many lines of code on the screen. Here we go. All right. So where was I? So the problem we have here now is we've managed to apply a validation on the health to limit the max health value, and we can set it both through code and also in the inspector. So this is a lot of lines of code we've written, but the thing I'm really trying to focus on here is the fact that each line has a purpose, right? We didn't write them arbitrarily. Each line solved some problem that we had. So up till now, we have the ability to set the two, but there's still an issue that you'll run into with doing this approach, which is we now have to maintain two clamp values. Clamp here and clamp here. It may not look like much, but this is a duplication of logic where if the business rules change, you have to remember to apply the rules in both places. So something I like to do in this instance is I would like to use the same thing twice. So in onValidate, validate will allow you to run other functions because it's just a function like anything else. So if I instead write set health and I pass in the max health value, I'm now running the same validation logic in both places. So it may look like the same thing, but what we've got now is a single place where our business logic is applied. The business logic for this application is health values must maintain a range between max health and 0, and it should, regardless of how you change it. So let's give this a quick test, but it should work. If it doesn't, I'll be very surprised. So I can now set between 0 and max health, and oh, it's still running. I can set between 0 and max health, and then the MVC tester will change the value to match max health value. So where did I go from here? So this works, but oh wait, it's clamped at max health. It should be clamped at health. My mistake. Just wondering what was going on there. So 0 to max health. So if I set max health back down to 100, health value 0, 100, desired health is 100. If I now increase max health to 121, I can now go to 121. And if I run it, I can now go desired health. I can set it down. It'll only go to 0. And if I go all the way up, it'll only go to max health. So this works, but we're getting into a stage now where the code is too verbose. So this is the feature set we want. We want to be able to change the code both in scripts and in the inspector and have all of this validation. But quite frankly, this is a lot of code to write. And this gets into the question of what a mutator is. And so before I do this, I want to add the second half of this problem, which is right now we can set the health, and the health is private, but we have another problem, which is, imagine if we had, I'm going to call it health UI. We're not going to make a health UI. I'm just going to use this as an example script. But if I was to put in a reference to the MPC, and again, this isn't best practice. We're focusing purely on the FEC script. Everything I write here is just hopefully the quickest way to get the message across to what I'm going for. So imagine we had a, I guess we can say a text mesh or something. I'll just do a print for now, because it doesn't really matter. If this was a text mesh you were printing to, you might want to print out the MPC's health value. So you would try to go health MPC dot and print the health. But the thing is, we can't see the health because health is private. And we're back to that same problem. How do we get access to read the health value in a display like a health bar, as opposed to the way it is at the moment? Now, we can't do that. We can't do it because it is private, but we could make it public, and that would let us write the line like this. But we're introducing all of the bugs we had previously. If you make a field public, all of the validation issues we had don't apply anymore. So how do we get a public access to the health value despite the fact that it's set as private? Well, we did a mutator earlier. The second half of a mutator is an accessor. So if we go back to the code, we have a mutator here in the form of set health. And what we can do is we could add a accessor to match. What does an accessor look like? Well, it's just a function that returns that value. So get health. What does get health do? It literally returns health. So there we go. Get health, set health. It's kind of self-explanatory. As for why we do it, hopefully now it makes sense, right? The reason people write accessors is to avoid the limitations of having public fields. So if I was over here now, and I had, again, this horrible printing function that should really be fired in an event and not called every single frame, but we're not going to get into event distribution at the moment. That's for another day. But we can at least do this now, right? We can say get health and potentially print the value of health. And you know what? Just to be particularly safe about this, because just in case people panic about the terrible practices, I'm going to say show or update health. Just this will make me feel better at least. Update health. And we will just print it in here. I'll do a quick context menu. Update health. At least this way it's not updating every frame and I don't feel like I'm doing horrible code. Right. Let me just drag the NPC in again, and just to demonstrate, if I run this, I can update the health and print it into the console. So you can kind of see over here that the health value has been printed. So we've now got access to read it as well as to set it. Right. We've covered quite a lot so far, but the next step is to move into the question of what's the difference between fields and properties. And this is where we have a look at the code again, and we have a look at these two things that I've called a accessor and a mutator. But a lot of people don't realize this. These two are how you approach it in most scenarios. So if you work in Java, for example, this whole accessor mutator thing is the common approach to solve this problem. But in sort of the .NET world, there is a more common approach for this that you're more familiar with, but you might know the name of it. You might have known that it was actually a mutator and a accessor, which is properties. So if I was to instead change this and call it underscore health. Now, some people don't like the underscore health naming, but it's personal preference. I quite like it because it tells you that this field is at a class scope. What you can do now is I could say public int health, and I can get and set the health. And this is actually a mutator and an accessor in one. That's what the get and the set is. It is the same thing as me having done the kind of more verbose, dramatic version that I did down here. That's what this is. This is a mutator and accessor. This is the automatic version. Because what happens is when the code is compiled, it will actually show, it'll turn into both of these. And I'm going to focus on the code a bit more for this. So let me just jump over here for a second. So I want to show the comparison difference here because the editor doesn't really matter from this point. What I really want to focus on here is through step-by-step building of this problem and sort of solving it, we've written these two. We've written a get health and a set health because they solved inherent problems we had. We needed to keep the field private for the reasons we discussed earlier, but we still needed to read it and we still needed to set it. So we got to this point, but we've written a lot of code to get there. But the thing is, if I get rid of these and use this property, that's all it is. This property actually is a accessor and a mutator. So instead of all of this setting health stuff I was doing, I can call this property instead. And that may look weird, but we'll cover that one in a second. And I can now go over here and I can say mathf.clamp between 0 and max health. This is technically the exact same code that we had earlier. It has just been squashed into one singular function. So if I head on back over it, these are broken now because these used to be calling the mutators. But now that it looks like a property, I can do this instead. And this is what's cool about this. I change these both back. Both of these scripts look as if it's public. So I really want to pause here to really focus on that. This line looks the same as if health was a public field called health, because it functionally acts the same way. You can see .health equals. You're not using a method, you're not using a mutator function, we're just calling it just as if it was a public field. But through all of the magic steps of applying the mutator, putting it inside of a property, you're actually getting that free functionality, but you still get to keep the ability to perform the clamping validation inside of the setter here. Just to really focus on that, we're back to really simple code over here. It doesn't even know it's a method, but it's actually calling a mutator. And over here, it's really simple. It's just printing out the health value, but it's actually calling an accessor method to access that value. So this was a lot to cover, but I hope I've demonstrated from each step that each one of these keywords has a reason to exist. They aren't arbitrarily chosen. You don't just put serialized field on every single property you have in every single field you have in your game. You don't need to make public properties for every single attribute in your game. Each one of these things is trying to solve a problem for you. So the reason you use this property syntax is when you need to apply a validation, which you wouldn't be able to do if you had made this field public and was not using serialized field. The reason you use serialized field is to get back the editing functionality you don't have if it is set to private. The reason you use an onValidate function is because the accessors and the mutators are only being used for code. They're not being used inside the inspector. So this method gives you validation at editor time. This one gives you validation at runtime with your code. But to avoid having to write the same thing twice, you can call the mutator, which is this one here, by resetting it to itself, as strange as that sounds, invalidate, so that when you edit the values in the inspector, it will rerun its own mutator to edit those values. So, hopefully that covered a lot of steps on something that people consider to be arguably very simple. Just a straightforward health value with a straightforward min and max health set, the ability to set it, and the ability to print it. Changing values to whatever your desired one is within range, and updating it inside of the inspector. So if I head on over just to demonstrate this one. So just as a reminder, health values clamped here. You can increase the max health values, and you've got the tester script you could run to assign direct values to it. So I'm going to take a... Oh, is the setter wrong? Good point. Let me check that. Set is... Oh, sorry. That is very true. Someone pointed out there's an error at the moment, which there is. This is my fault. So I want to point out something here. Inside the setter, let me just remind you for 1 second. Before I do the real fix, I'll demonstrate what I did wrong. So if I go back to set health, desired health, health equals desired health. So this was our setter, right? This was our mutator, and you're setting the health value equal to desired health, and this is where we were originally performing the clamp. If I put this back here, this was supposed to be like this. This was our original mutator, and like I said, we've moved from this to the mutator inside of the property. But when you use a property mutator, it uses a default keyword. Instead of desired health, like I've written here, it's supposed to be value, so lowercase value. So that's my fault. This is supposed to be value. Value is the incoming value you're receiving inside of your mutator. That's the same as this value here. So when I pass in desired health to health here, the name of that is over here is lowercase value. So that was a bug I introduced, but there we go. Hopefully we're back to working again. So sorry, here we go. We'll double test the code again. Value is being passed in from the setter, which is being clamped between 0 and max health, and is being assigned to health. And because we're using it in the onValidate function, you're now managing it in both cases. So let's double check that all works. So we'll set health to max health to 100. We can clamp between 0 and 100. We can't go any higher. If I try to set to -50, it won't let me. If I set max health to 220, I can now go between 0 and 120. If I run the application, it'll set the desired health to 100. If I scroll it down to 0, even if I have a desired health that's lower, it'll clamp to 0. And if I go all the way back up to higher than max health, it'll clamp to max health. So regardless of whether I'm changing it inside of a script or changing it inside of the inspector, all the validation and clamping works. And if I was to print it, it will print correctly into the console. Well, only one bug introduced. That's not too bad. Right, so I'm gonna pause there because there's a lot of things I've covered, and I want to see if there's any particular questions in the chat before I move on to other things. As for people saying, what are the correct approaches to other things, like how should I be referencing the other fields inside of the scripts, or how would you handle events or dispatching, I'll cover those one day, but right now there's enough information in this that this is what I want to stick with. Oh, and by the way, for people who are curious, this whole getter and setter thing, I'm using what's called expression-bodied members, or expression-body syntax, which is this arrow. You don't have to use the arrow for the lambda. That's just a way of, if it is one line, I personally like all of this because it makes things a bit cleaner, and because I didn't have the foresight to put enough space in my my Streamlabs setup to give you more lines of code to read, it's been easier to just squash it down to one line. But keep in mind, any place that I've done this, you could alternatively just go back to your curly brackets and go back to method body syntax. So that is your normal method body syntax, and you can do that for all of these, for your getters and for your setters. And you do the same thing for, but if you're doing it as a full version, you have to actually return the value yourself. And set, you can do the same thing. So just so you can actually read the code, here we go. So as I said, alternatively, you can do the verbose long form version of the accessors and mutators. Oh yeah, and obviously someone else who has OCD is pointing out that these should probably be somewhat close to each other, as they're both fields that you should be able to access. And yeah, so right, this is so again, just for anyone who is curious, you don't have to use the lambda syntax. It's just, if you're using writer or something, you'll actually notice it'll tell you. You can use the expression body because of inconsistent styling. Because I in most of my code, I tend to favor the lambda syntax because it's just shorter. But again, not mandatory. It's just a nice thing. If you've got more than one line, you can do it there. There's another issue that I'm not going to cover too much here, but when people are talking about events and things, there's another advantage to this sort of setup, being the fact that this is called in both the inspector and also in the code, is hypothetically, if I was to write on health changed here and print if I head back over to the inspector version, I should be able to change the health. And did I write max health or health? Yeah. So I'm able to change the values here and get the printouts for when the events change. So now it's not happening live. It's only happening whenever I actively change the values. So just collapse some of those. So you'll see now that this solves that question people were asking about how do you avoid doing the update regularly. Now, obviously, I don't recommend printing constantly every time you change the value, but it's just pointing out that's the place where you would put that logic. So you can now do something where you'll get messages whenever changes happen. And that works regardless of which method you're changing it. Whether you're changing it from the live code, whether you're changing it inside of the editor script. And we can get into other stuff like how should you be dispatching your events. Like, for example, some people would prefer to fire the Unity event here. There's some overhead and cost to that. You might also want to put in something like make sure it only fires when it's playing or something. Like, there's all sorts of different rules you can put in. But the only reason I even mention this is the whole kind of lesson between all of this is the fact that public fields they have a life cycle that you cannot interact with. You've made it public and you've made your bed. You have to just, every script that wants to access it has complete and utter free reign to change that value, do anything it wants to. And in health, worst case scenario, you set health to -20. But if that public field is a game object, any script in your application can just null out whatever that value is. So you've got this public player field that you've got accessible on your script, and anything can just decide, I'm going to set that to null. And all of a sudden, your entire application breaks. So the benefits of using the property solution and giving you the accessors and mutators is that you can do anything you want with that lifecycle. Right now, we are doing validation logic, and then we are dispatching events on change, which can go off and do other things, but it can be anything you like. Another common example of this is you could have a field like, start with public float health %. Now, we have this health % field, and we can kind of be messy with it and go in here, and every time health changes, we can calculate out the health % and, do it that way. So what are we doing? Let's we want to set our health to there's max health divided by 100 multiplied by health. But the problem with this is that we're doing it inline in every time this is being set, but this value won't be accurate unless there's an update. The only reason I'm mentioning that is you can have things that are calculated fields. So part of the whole accessor thing is if I switch to this to get and set, what I can do is I can get rid of the set portion. So now we've got an accessor, but no mutator. And there's no way to set this value. Now you can do things like private set. And what's cool about this is that means you can only set it from inside of this script, but you can access it from outside of this script. But you can go one step further and you can calculate out the value. So you wanted to, you can assign direct values here, or you can say, what was it before? max health. So you can basically have a calculated field. And for anybody else that's using this, where did I have that printer? Health UI. Oh, I was doing it in the event, wasn't I? Yeah, it's fine. So I can change this to health percent, and it still has the same benefits. It still looks like a field, but this actually isn't even a float. It's not a value at all. It is a calculated method, effectively. This is too far down the rabbit hole. I don't want to go down into too much details there. I just want to point out that we've come full circle from this is a field. If you're discussing it, that's what this is. It's either a field, which is either a public field or a private field. We'll say this is a property and specifically inside of these, this is a mutator and this is a accessor. And I'm hoping that through stepping through these phases, it's clear enough at least why each one of these things exist and the differences between them. So I'm going to take a break from coding because I just realized that I messed up that percentage calculation because I'm feeling a bit frazzled at the moment from all of this typing. You'd be surprised how stressful it is to type live while people are watching. That's why I normally am more than happy that Charles does it, because I don't like the scrutiny. By the way, I apologize. I'm also trying to read the chat at the same time, and like I mentioned at the start of the stream, for anybody who missed it, because I'm streaming on Charles's channel and not my own, I'm having to sort of hook into his channel system, and I don't have access to the chat live that you would do if you were running it yourself. Instead, I'm accessing the chat at the same delay that everybody else has. So I apologize if I pause and look confused from time to time as I try to figure out what the chat's saying. Right, so how long have we been at this for? I probably should have written the time down. I'm going to give it 10-15 minutes to answer any questions and kind of go over that and see if anybody is particularly confused. One of the questions I have here is accessor and mutator the same as getter and setter? Yes, getter and setter is sort of the friendly term for it. Accessor and mutator is the sort of clinical programming term for it. So you'd be more familiar with this if you work, again, Java as being a good example of this. Java doesn't have properties. That sort of shorthand magical syntax. And if you decompile your code while using a property, it will turn into a normal getter and setter. So yeah, you can call it getter or setter, you can call it accessor or mutator. I just like to mention the clinical version of it because it means if you're Googling it, you'll get a lot more use out of describing it that way. I didn't cover as well the printing I was doing with the colors. I don't want to get sidetracked. There's a million things I could cover here, and I don't want to focus too much on the nuances of the way I particularly print messages or something. I really wanted to focus on the lesson of this whole discussion here is when you've been coding for as long as a lot of us have, or when you've been using Unity as long as we have, and I'm talking about all of you as well, not just me, you get into this sort of kind of autopilot where you start writing code, and it happens at every level. At the beginning, it happens in, every time I make a variable, I make it private, I add serialized field, next private serialized field, next private, and you just do it automatically, but you don't think about what it is for or what problem it's solving. And the same thing applies if you're more experienced. You might find yourself starting a new project and going, well, I'm going to need a factory pattern and I'm going to need a builder for these objects, and it's just this whole mess of stuff that you kind of forget the point that every single line of code is meant to solve a problem. You shouldn't be writing lines of code because conceptually they might be needed at some point, or because you're used to writing them, or you think that they're how cool programmers do it. It's worth taking the time from time to time to take a step back and ask yourself, what is the problem I am solving by adding this keyword? I don't even mean like this method or this feature or this mechanic. I mean, sometimes ask yourself, why is it public? Because there's some really interesting stuff that people don't think about, which is when you start getting into some of the more advanced design pattern stuff, like humble dialogue, there's cases where you have public setters with private getters. And if I was to start with that and say there are some cases where you might want to have something publicly settable but not readable, that might seem weird to you. But hopefully, at least by demonstrating through all of this, you might see that there's actually cases where maybe a script doesn't want to tell you what it is, that you can set it, but it's not going to tell you what the actual value is. And yes, C# properties are literally just get and set methods internally. Like if you decompile your code, it will become a get and set function. One of the questions here is, can you display a property in the inspector without your own reflection logic? No, at least not that I know of. And there's a very good reason why. So when we wrote the original public int health, that is a field. It is literally a value. But like I was trying to describe with the health percent, it doesn't necessarily have to be an actual value, right? You can have a getter/accessor, which is actually just a calculated field, or it could be a hard-coded number, or it could be literally anything. And so conceptually, Unity isn't able to serialize something that may not even be an object at the time of you calling it. So there's not really a sense, even if it did try to serialize your getters and setters, it wouldn't make any sense, because that's what it's doing in the inspector, right? It's drawing serialized values, and it's probably a bad idea to try to do that when conceptually those values can be compile time changed. So no, there's not a good way to serialize the getters and setters. Yeah, there are some other attributes out there that'll do similar stuff, and we can do that one day as well. So the example I showed here is a raw single field. What are the ways in and around a single field that you can do fun validation and logic? But you can go beyond a field, right? Once you start getting into more advanced stuff, you can talk about configuration data and settings. And that's where you start getting into how do you pass around configurations that can change. And maybe it's worth having a scriptable object that you drag in that gets configured and set up, and that every time you update the new scriptable object, maybe you configure the whole thing. Or maybe you make custom property drawers that includes the validation, so you don't actually have to write the validation in a getter and setter. You actually put the validation in a custom property drawer, so the value has the validation baked into it. There's lots of other more advanced topics we can cover around this area, but there's a lot in it. And so I really want to focus on just this one piece first before we start getting into how we use custom editor extensions and property drawers and writing our own scriptable object validators and stuff. And that will extend this idea to include some of those other topics, like how would you have multiple validation or have things relying on each other, or, you know, cache out a collection of settings that you can then swap out like different parameters. And this is all separate from the fact that there's actually Unity stuff that does that. So for people who aren't familiar, I don't want to get into it either, but if you have a look at saving settings in Unity, there is actually a little icon in the corner, and you're able to save out preset configurations of how an inspector looks. So if you have a particular subset of variables or parameters that you like, and you want to sort of say, this object configured like this is something I'd want to use again, you can do all that without actually relying on a lot of custom serializing and that kind of thing. But again, we can cover that another day. I really do think we've covered enough in terms of that kind of data. Passing values through events, good or bad, updating health bar on every hit. Well, this is one of those things, right? So having stepping through this process, the question, like, is it bad to update on every hit? Think of it as per what we just did. What is the requirement? Is the requirement the health bar should update every time the health changes? Well, in that case, you'll need somebody to distribute some message when the health bar changes. So it's not bad, it's literally a requirement. So once you put in that requirement, you can then decide who's listening and what to do with it. As for, is the method of dispatching events I have chosen the best one? That's a different story. And we can go into, should you dispatch events using notify property changers? Should you dispatch events using the Unity event system? Should you use actions of your own delegates that you subscribe to? Or should you use a signal pattern or an event bus? There's a million ways to dispatch it. But I kind of want to detach from that for a second and say, these are all different concerns that'll have different pros and cons depending on your project. But none of that affects the fact that you will still need some function, some spot in your code to say, the health has changed, do something with this information. There are pros and cons to what you do with that information and which dispatching method you choose to use, but there's no downside in having a method there that hooks into the lifecycle to give you a place to make that decision later. And so a lot of the more advanced questions that people talk about in terms of should I save to JSON files, should I save to text files, should I use Oracle or MySQL or whatever else, I want to kind of get people to detach from that idea that these are implementations that you can pick, but the idea of saying I can architect my system so events happen and I can dispatch some method or call some function that will happen when this occurs, they're two different problems, right? You can write your code to say health has changed, health has changed, health has changed, and then somebody else using some other system can attach to that and apply some rules to it. So never feel afraid to dispatch method calls, because that's pretty much your actual requirements, right? As for which is the right solution, that comes down to hopefully following the guidance of this kind of stuff I did here, is step through the problem. Don't just say, I'm going to throw an entire SQL database at this problem. Ask yourself, what are the implications of doing that? What do I need it to do? What is the simplest version of moving one step to the other? Because keep in mind, we started with int health. It was just one line. And just adding a very simple requirement, I want to have max health that can change relative to it, ended up bringing us down a rabbit hole of cause and effect. Just adding this makes me have to change this, or we have to change this, and it changed a whole load of things. So when you're deciding whether something's good or bad in terms of event dispatching, there's a lot of concerns that'll crop up that you'll forget when you start going down that rabbit hole. So again, don't worry too much about which implementation you're picking to solve a problem, but just make a point of stepping through the problems and applying the simplest solutions you can, and the more complicated solutions will sort of make themselves known as you go, right? If you need to drag things in the inspector, maybe use Unity events. If Unity events are too slow, maybe use something else, right? Like, rather than saying blanketly, this is good or this is bad, think about what the problem is you're solving, apply the tool that solves that problem. That listener only gets called, changes. Seems like there's a back and forth in the chat. I don't think we have any questions. I'm more than happy to call it there, unless somebody has a particular question they'd like to ask. Like I said, I don't want to get too deep into things, so if you have simple sort of theory questions, I'm more than happy to answer them. But if there's something like, how do you expand this to mono behaviors or serializable references or fields, I'll leave that for another video. If people have questions like that, leave them in the comments in the video, and I'll come up with other videos that will extend on from this idea later and hopefully cover those in more detail. What do you recommend to learn nuances like that for C#? Okay, so the term for those kinds of things that I've used, in that case, the things like the expression body members, things like the accessor and mutator stuff, those kinds of things are always under the banner of something called Syntactic Sugar. And that's sort of the universal name for what features in this programming language make my life easier. What automates things for me or does sort of fancy tools or whatever. So if you're Googling in general, you could say, look for C# Syntactic Sugar. If you want to know how to apply some of these things and what's good ones to know, I recommend Pluralsight. Pluralsight has it's called learning paths. So they have actual kind of structured paths that teach you about different topics. And one of them is just the C# learning path. And they have it in the 3 sections: beginner, intermediate, and advanced. And if you follow through that course, I think it's mostly in the intermediate, but they do cover a lot of these things. Things like operator overloads, writing your own custom reference equality. What else was there that was fun? The params keyword, if you haven't used that before, that's another fun syntactic sugar. There's object initializer syntax, that's great. There's collection initializer syntax. There's null coalescing operators. There's a whole load of these other syntactic sugars that will make the code cleaner and let you sort of focus more on what you're doing and have the compiler automate a lot of the grunt work, like getters and setters being turned into properties or so on. Right, so I think that's me. I'm going to call it there. Thank you everybody for watching. I hope there was some nugget of information there that was actually useful. Just to repeat one last time, don't worry too much about the lines of code I wrote. It doesn't matter so much what I actually wrote in terms of literal lines of code. I'm hoping if there's any lesson to what I said here, it was that you don't have to do it with every line of code you write, but from time to time, just as an exercise, take a step back for the next thing you're writing and ask yourself what every line is, right? Why did I write the word public here? Why am I making this? Do I need this method to be public? Do I need this setter? What are the implications of this? Will someone else need to change this elsewhere? Will this have any knock-on or side effects? And if you just start to think slowly through the code and tie them to the actual requirements, because remember, when you sit down to write code, you're not writing code arbitrarily, right? You decided to write something. You're making a character controller, you're making a game or a health system or something. So you actually have a list of requirements. I need it to show health. I then need to set the health. I then need to limit the health under certain conditions. I need to apply a bonus to the health. These kinds of questions. And if you remember what line of code I'm writing, which one of these requirements am I actually doing, you'll find a lot of the code that you take for granted you mightn't actually need to use, and you'll find that a lot of the sort of default code you write might actually be overkill for what you need. And it also might help you figure out, why do people tell me to do this stuff? Why are people telling me to use serialized field as an attribute? Well, there's a very long-winded and good reason as to why. So, thank you everybody, and goodbye.